Hello students, a very warm welcome to JEE English by Unacademy, India's leading and largest JEE test preparation platform. And students, today we are on the sixth session of your current electricity. By now you must have gone through lots and lots of your PYQs and you must be near about your end completion of your revision. We'll be discussing few more concepts and we'll be concluding your PYQ sessions of current electricity very soon. If you have missed it before, we'll be having a special class where you can attend these classes with live polls and leaderboards, so do not miss it out. And there would not be any separate sessions for 2020 PYQs, so try and attend those upcoming special classes on your Unacademy learning app. So this is going to be this Monday, don't miss it out. And that being said, yeah, today we have some tricks that we'll be discussing that we try to do in every PYQ session that you can apply in your JEE Mains. And don't worry about it because you're going to get into this topic with an electrical engineer, and I've completed my MS in electrical engineering from one of the top ranking university, and I'm also an IITian who completed BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE into the competitive exams, and I filed 25 patent applications in India and abroad. And that being said, students, if you are looking for a complete package for your JEE Mains and JEE Advanced preparation, it's going to be an Unacademy subscription, because we provide you the test educators across the nation, like DC Pandey and DC Gupta sir, who will be teaching you on an Unacademy subscription platform. In fact, you'll be attending daily live interactive classes with these best educators on a very interactive platform with polls and leaderboards, and that way you don't have to worry about your learning not being fun. In fact, your learning will become super fun during this period. And not only that, you'll get to attend lots and lots of test series set by the best educators, along which you'll be also getting analysis on them, and you'll be competing with the national level crowd, and you'll be getting an analysis. You can improve upon your performance depending upon what you have been doing your test series. Like, based on your mistakes, you can improve upon it, and we'll provide you the relevant analysis for those. And not only that, you will also get access to lots and lots of live doubt clearing session. And in fact, every program is going to have that. Every program on an Unacademy subscription is going to be a structured program. You will get access to lots of live doubt clearing sessions on an Unacademy subscription platform, and with those you'll be also having lots of quizzes and mega quizzes on an Unacademy subscription program. So this is going to be one of the best things, and we do not restrict you by any batches. You will have access to multiple batches, unlimited access. In fact, you can access as many things as you want. But 2021 aspirants, plan your preparation smartly. That is one of the most important things that you should be focusing on. And how do you avail an Unacademy subscription? All you need to do is download an Unacademy learning app, or you can do it from web-based version. But having an Unacademy learning app on your mobile phone is going to give you live notifications. So try and have an Unacademy learning app handy, and click on this left hand top corner extension bar, select plus, and log in first of all, and then select this IIT JEE as your goal, and then hit on this get subscription button. That's all you need to do. You'll be having redirected to your depending upon your preference or whatever you want to go for. You'll be getting access to the payment page and your program time period, and which is that one that you want to go for. It depends upon where you are right now. Let's say you are a 2021 aspirant with a plan to drop. Okay, so 2021 aspirant might not be the ideal time, but with no plan to drop, okay, if you have no plan to drop, or you are already a dropper, you want to go for a 6-month subscription, which is going to cost you only near about 25,250. And let's say you are a 2021 aspirant, you have a plan to drop. Might be the time to plan now, might not be the time to plan now. It depends totally upon what you're going to do. And let's say you are in 11th class right now, you may want to go for 2021 droppers plan. You want to go for a 12-month subscription, and of course that's going to cost you less than 34,650. And students who are just getting into 10th class, or who are getting into 9th class, or who are in 11th class but haven't done even 50% of the preparation, you may want to go for a 2-year subscription program. And 2023 aspirants, this is a very good time to start because we have batches that have been begun by some of our best educators for 2023 aspirants as well. and many more things even for 2021 2022 aspirants. So don't worry about it. Depending upon target, we have many programs. We'll be discussing those as well. And yes, that is going to cost you, like if you go for a 2-year subscription, it's going to cost you like 25,000 per year. That's like 50,400 for 2 years. And this is about plus subscription. We have something beyond plus subscription known as iconic subscription, where you don't only get access to all the features of plus, best educators, best platform in the form of structured programs, where you don't have to worry about the planning. This all can happen on iconic as well. So what is the additional thing about iconic? On iconic, you can get personal mentoring session, one-on-one mentoring session, personal coaching from IIT and NIT alumni who are educators on our platform. So the best thing about iconic subscription is you'll be guided throughout the process. It's not just about lectures. We'll be also providing you many more things. So think about it. IITians and NITians who have previously gone through this journey, they know the ups and downs in this journey. And not only that, they also can provide you the strategies, because they have successfully cracked the exam. They can provide you with the strategies that can make your journey hassle free. And not only that, many more things can happen. You'll be getting personal guidance, many more things depending upon your preparation, depending upon where you are right now. And this all can happen on iconic subscription, and there are many more things that you'll get on iconic subscription, study planner, etc. And what is the pricing of iconic subscription? And iconic subscription is only going to cost you 34,200 if you go for a 6-month subscription. If you go for a year subscription, it's going to cost you 58,500. If you go for a 2-year subscription, it's going to cost you only 90,000. So that's going to be like 45,000 per year, right? Make sure you apply Murli Life code, be it you go for 6 months, 12 months, 24 months plus or iconic subscription. Okay, so this is for your maximum discount, students. Don't miss it out. So yes, make sure you apply Murli Live code and don't miss it out. And that being said, we have recently introduced something known as combo subscription. So what is this combo subscription? Students, combo subscription is a combination of your IIT JEE and CBSE board preparation. So now you can get your CBSE board preparation and IIT JEE preparation in one place. With the best educators across the nation. That can now happen on Unacademy at a very economical pricing. It can go as low as less than 90 rupees a day. If you go for a 2-year subscription, it can go as low as less than 120 rupees a day if you go for a year subscription. And of course, we do have best educators for your CBSE board preparation as well on Unacademy subscription. So if you're looking for one such package, a complete package for your JEE Mains and CBSE preparation, it can now happen on a combo subscription. And make sure you apply Murli Live code on combo subscription as well, because you'll be getting discounts. So don't miss out the discount. Okay, and that's it. So let's get into this amazing PYQ session. Hi JEE aspirant. Hi. Hello students. So a plan is the most important thing, as you know, and your passion, your drive should be present. Without a plan, so there are two things that you can think about your planning. One is you have a plan in your mind, other is you have a plan on a paper. Okay, you have a plan on the paper and you are following it. You have a plan on the paper and you are following it. So follow your plan. So it's not just plan, but a plan on paper, not thinking in your mind, this week I'll be finishing current and electricity. Plan realistically, maybe 2 weeks you give for current and electricity, or 2.5 weeks you give for current and electricity, 3 weeks, depending upon the weightage. A very smart plan. A plan is not just your study plan, but a study plan systematically analyzed. You have all the kind of things that you need to understand and the way you should be approaching, and why you should be doing it. You should be knowing it. It's not like just you have a plan because this is an easy chapter for me. It should be like, this is the chapter that will get me the marks in the exam. You're ultimately writing a competitive exam, so think from that perspective. Of course, you might love physics, you might love chemistry, you might love mathematics, but that is secondary when you're giving JEE. If you are not an aspirant, but like someone who's enjoying physics right now on this channel, so think about it. A plan is going to help you in your life. Of course, a very smart plan is going to be the best, and there is definitely no substitute to hard work and your passion, your drive, that you will be able to do things. Alright, let's get into this chapter then. Let's get into today's session. And of course, there is a shortcut for this question, students. So think about this question. This is one of those questions. We can solve this questions in 2 ways. I'll be discussing both the ways, but think about the shortcut for this question. Okay, so what is given to you is like, some unknown. I'll explain you the question, don't worry about it. So there are two unknown internal resistances, and you have two batteries or having same EMFs, right? And these two voltage sources, what is the total EMF? 3 volts. Depending upon the internal resistance and the network resistance, some current is going to flow into this network. Okay, now the question arises, like what has been given to you in the question, some 2 volts is dropping across whom? Just the 10 ohm. That means that 2 volts is also dropping across 15 ohm, because they are in parallel, same amount of potential is going to drop. Okay, so think about it, 10 and 15 in parallel, what this is going to give you. This is going to give you something like I think it's going to give you like 5 by 30. Is that what we are going to get? Yes, I think so. So 5 by 30 is going to be 6 ohms. 6 ohms, 2 ohms in series, right? We will be solving this, don't worry if you are not understanding it. So 6 ohms and 2 ohms in series, and if this 6 ohms, okay, it's how many volts? It's going to be 3 volts, which is 3 times 6 ohms is 3 times your 2 ohms, is consuming 2 volts. How much do you think is 2 ohms going to consume, or the rest of the circuit is going to consume? Think about it in this manner. Rest of the circuit is going to consume along with the 2 internal resistances. So basically 2R. I'll get to this detailed solution, don't worry, just focus on this. Try to understand this point. So there is a total internal resistance and 2 ohms together consuming how much? Remaining of that 3 volts. Okay, remaining of the 3 volts, how much is that going to be? Like 1 volt. Is that it? So if it's 1 volt by 2 ohms and 2R, then we don't know the distribution. You can calculate it using one is like resistances ratio. Okay, that is one thing that you can do. But definitely think about it, what should be the ratio of them, so that you are getting 2:1. So that should be 3 is to that should be 3 ohms in total. That means 2R should be 1 ohm. That means your R should be 0.5. Not getting too much into the details, this is how you can proceed with the question. Okay, now let's get into the proper solution. 2 types of solution that I'll be discussing. One is going to be like a standard solution that you can apply if you get one such question. Other is going to be for this question specifically. Okay, for this question specifically, what I'm going to do for both of them, for both the methods, you need to have an equivalent circuit, and in that equivalent circuit, what is this? We have just calculated this part. This is 6 ohms, you know this thing, right, between this network. How do we know this? You know this thing. It's basically 1 by R is equal to 1 by 15, basically 2 by 30. Can I write it as 2 by 30 and then 3 by 30, 1 by 10. That's going to be 5 by 30. So that's going to be 6 ohms. Okay. But that thing should be present in your mind, that 10-15 goes well really each other. Then you have this 2R. Okay, then draw the equivalent EMF of the battery. That's going to be, now one approach, standard approach is draw the current, find out the current. Both the approaches are short if you're thinking that way. Okay, let me go one by one. Okay, so here is the thing, both are literally the same if you're thinking about it. So one thing you know is across this 6 ohm equivalent resistance, 2 volt is dropping. Okay, that means how much is left? 2 minus 1 volt should be dropping across the series combination of 2R plus 2 ohms, or 2 I could have written it as, should be consuming how much? Just 1 volt. It's all series, right? So can we say something like this, divided by 6 ohms should be your 2 volts. Okay. This recalls all your basics. So then what do we have? We have a very simple solution. From here we know 2R is how much? Two R is like 3 minus 2, 1 ohm. That also implies how much is this? This is going to be 0.5 ohm. Simple. That's what we discussed initially. And the next standard thing is you think about current. Okay, let's get into that part as well. Let's get into that part. It's also simple. Okay, it's also very simple. Same thing, basically same thing. Here we have taken ratio of potential, and there we would be dealing with current. Same thing. But generally current is little standardized, you know, because there can be another set of parallel resistances, etc. You know, the net current in the circuit, it's very easy to predict what is the leftover voltage that has been dropped. I don't know, even I think voltage dropping is the easier method according to me. Okay, because directly taking ratios are simpler rather than going for that. I don't know, it depends totally upon your question. You want to make the decision depending upon your question, but start with one approach and move to the other approach. Voltage approach is of course going to take you lesser time. Voltage approach is the best one because it's a two-step question. If you're going by voltage, literally 2 lines, right? 2 lines if you're understanding it. Okay, 2 or 3 lines max to max. And if you are going by this one, it's going to be 3 line or 3 step. Okay, equivalent we know is 6 ohms of this, right? Now how much potential this is consuming? 2 volt, right? So what should be a current? Your current should be 2 by 6, basically V by R. So something like 1 by 3 amperes. Is that it? That's the net current. What is the leftover potential? Same concept. Yeah. At the end of the day, we are coming to the same concept, and this is going to be 2 plus 2R into I is going to be like how much? 1 volt. Okay, 3 minus 2. It's the same thing that we did earlier. Okay, anyway, we don't need any explanation on this. So you know it's 1 by 3, same thing that we are getting if you are noticing this, but these are 2 approaches you want to understand. Okay, so R would come out to be again 0.5. But sometimes that one can be shorter, given that, you know, it can be a different kind of network. All right, so let's get into the next question. Of course, there is an approach in this question. I'll come to that approach part. And what does this question say? So you have a meter bridge and the circuit diagram is given and the corresponding table is shown. Which of the reading is inconsistent? Okay, so this resistance box is the one that you're going to change. Remember, this is going to be a variable thing, the meter bridge, and you try to tune it to the near about half value to get the most accurate value. Okay, how do you work around this question? You do each and every step to get the answer. Other ways, how do you approach this question? No? Think about it. Multiple R, 1 ohm is given, 10 ohm is given, 100 ohm is given, 1000 ohm is given. There you should be beginning. There is typically a hint around this kind of question. You want to start around which one, students? Least length. Okay, definitely if you look at both of them, this is increasing by 1.5 times, whereas this is increasing by 10 times. Okay, This is increasing by how much times? Near about 10 times. This is increasing by 10 times. Okay, this is increasing by 10 times. This is increasing by 5 times. Near about 5 times. Okay. Now, if you are thinking about this carefully, you need, of course, take the ratio. Then in this case, I would always start with the smaller value. Most discrepancies can be observed near smaller values. Always. Huge deviations would be present. Okay. All right, let's get into it. Okay, let's start solving this question. I think answer might be 1 among 1.5 or 1.0 because discrepancies exist over there. You know, of course, let's label them. You know, this is going to be like R1, this is going to be like R2, this is going to be like R3, this is going to be like R4. What did you do? It's a meter bridge. Okay, so you basically have if this is length L, this is going to be 100 minus L. Okay, that's it. So now let's get started, students. Okay, so we know one thing, case number 1. Or let's start with case number 4. That's the mistake that you're doing. We have to always start with case number 4. Why? Smallest value. Maximum discrepancies can be observed near smallest value. So we'll be starting with 4, where you have an equation like this which says R by X is equal to L by R1 by X is equal to 100 minus L by 100 minus L. So 1 centimeter by 99 gives you how much? Because it's basically 1 centimeter. It's going to be how much? R1 by X. R1 is how much? R1 is 1 ohm. Actually, it's R4, isn't it? Okay, R4 is 1 ohm. And how much should be your X? 99 ohms. R1 is R4, sorry, R4 is 1. And next we'll be going for R3. Change the color a bit. Okay, and now what is R3? 10 ohms. Okay, and what do we have? Like 10 ohms by X is going to be some L 1.5. This could have been L4 by L4, and this could have been by L3, whatever, if you would like to keep it that way. But basically 1.5 divided by 100 minus 1.5, that is going to be 1.5 divided by 98.5. Do we have going by nothing? But this would have to go by 5. Let's solve it. Okay, let's solve it, and let's understand what this is going to be. Okay, here we have X, we have 10 on the numerator, so we'll be having 985 instead of 98.5 divided by 1.5. Okay, basically this is anywhere around much. Start solving it. It's not going to work that way, I guess. 9850. We need to keep an approximate value only. Anyway, you know there is going to be errors as long as the resistances are not going to match. So even if you are arrived at a discrepancy, you may want to stop calculating. Okay, let's do it directly. That is, I think, the best way to go about this question. This is 6 times, then you have 35, 2 times, then you have 50. How much do you have 3 times? something 623 is good enough to write down for now. Let's think about rest later, because first one says 99 ohms, second one says 623 ohms. First one literally says 99 ohms, or what you said. I think it says. Okay, now next is what we need to get into R2, R1. One, if we calculate this easy, I'm going to go for R1. It looks a little easier. First case, let's calculate and see for the second case as well, but first case looks very easy. So that's the reason we are going for R1 by X is equal to L by 100 minus L. In this case, L is how much? 60 by 40. Looks very easy. And how much is R1? R1 is 1000. And X is how much? What we have to find out now. 0 0 goes off. This is going to be 3 and 2, basically 2000 by 3. We have something like 666. Correct? So that's correct. Okay, 2 will keep on moving, so we'll be having 6.66 ohms. Let's not do it very accurately. Okay. So if you are looking at it, this is how much? 623. Little, it's not going to be exactly the same value. I told you this is going to happen even when you do practically. So if you're observing this, this is 623. This is like 666. Probably reading 1 and 3 are consistent. That means reading 4 is inconsistent. As I told you, in the smallest value, you're going to have the most inconsistent value. Smaller the value, more inconsistent is going to be a reading. Let's check out for 13 as well, which will be giving us a good understanding of thing. But we can think about it this way. How much is 13 by 87? You're going to have 87, isn't it? So that is going to be like 6 times 6 point something 6.5 times. So it's going to be like 650 and odd. So it has to be like around 600. Okay. So we'll be going for this. We can do this directly. By now you must have understood how we should be doing this. Let's take X is equal to R2 into that of L or 100 minus L. 100 minus L. My mistake. 100 minus L divided by L. Okay. It's really that simple. I'm writing down the same equation but little directly. We know it's 100 and 13. L is 13. Okay. 100 into how much? 87 by 13. 100 minus 13. So if you are noticing it, 13 5s are 65. 65 plus 13 is how much? 80. Just a moment, students. And how much is that going to be? Really a bad calculation. I guess 78. 91 is 7 times. Okay, 91 is 7 times. So this is less than 7. Near about 600 is what you're going to get. 600 and even do it accurately, it's going to be like 6. And we don't need to do it accurately anyway. 90. So 6.5 something we'll be getting. Okay, 6.5. And then you will be having 11 left over. 11 is going to of course give you 657, isn't it? So 657 something. So consistent, not very consistent but near about consistent. Okay, so that is how you will be also anyway observing the value. So the most inconsistent values anyway going to lie in the least value almost. Generally you want to start with the least value, and the calculation also looks very easy, right? 99 looks very easy. You want to get started with it. So the answer should have been okay, you know the answer, how to mark the answer, but in this case it should have been 4. Carefully, you have calculated everything carefully. Alright, let's get into the next question. Very amazing questions. It's literally an amazing question. Space between two concentric conducting spheres of radii A and B is filled with a medium of resistivity rho or P in this case, I guess. Okay, P, the resistance between the two spheres will be. How you are going to do this question? And a cylinder question. Very similar. In cylinder question, what is the thing that you can observe? Observe a log. In this case, will you observe a log? You will not observe a log because no log is present. Okay, one hint of analyzing such questions as soon as you see them, at least to not guess the wrong answer. See, basically some integration is involved. If you're thinking about it, some integration is involved. That means there cannot be a plus sign. It has to be a minus sign. Okay. Simple question then. Let's get into this amazing question. So let's say you have a sphere like this. How you are working around the sphere, students? You have a sphere like this. You basically have a connection, something between this position and this position. Okay, so it's going to flow like this, but spread across the surface area. Spread across the surface area. And is this surface area consistent or constant all the time? No. Length is something that we know, but this way it's going to flow. Over here, over here, over here, etc., etc. If you apply a potential difference between both. Okay, now the question arises, okay, how do we solve this question? That's the first question that arises, of course. We are going to take a small integral, a differential element to integrate it, of course. A small elemental value. What is that elemental value's thickness is going to be dx. So this dx, just in between somewhere at a distance x from the center, okay, it goes from where to where? From B to A. Okay, but now if you are taking the elemental, kind of sphere, it's a sphere, okay, elemental sphere, what is the distance that is just traveling? The thickness of that sphere, basically dx distance, where you do not have any variation in surface area. In that case, what is the surface area at distance x from the center? 4 pi x square, or area, basically. So now we know something. What do we know? We know what is the elemental resistance. What is the elemental resistance? Some resistivity P into length, dl length divided by dA area. Okay, this is nothing but dA area actually. So if you are noticing this, how much is this? Rho or P into dx divided by 4 pi x square. Okay, for most of you, now you know how to work around this problem. Now what you're going to do? You're going to integrate basically the dr. Let's get started on that. It's a very simple question. There is nothing so complicated about it. It's a damn simple question. So I'm just going to carry out the integration. Resistance of this sphere is going to be like integration dr. This is going to be integration how much P into dx divided by 4 pi x square, and this is going to go from where to where? From A to B. Okay, now P can be taken out, 4 pi can be taken out, and what do we have? We have something like dx by x square, and this is going to be a simple integration. What you have to differentiate so that you get x square, because I definitely want you to know this thing, this reverse integration technique, because in some cases, rather than doing it systematically, definitely that is the easiest way to go. Okay, we have P by 4 pi integration is going to be minus 1 by x. So think about it, minus 1 by x. If I differentiate it, what would I be getting? I'd be getting minus 1 by x square, 1 by x if I differentiate. So minus 1 by x is going to be just x. So this is going to go from A to B, right? And what should be this simplified, we will be getting the resistance of this sphere where you are connecting the sphere across the sphere. Okay, that's it. It's a simple, easy question. P by 4 pi should be present. Okay, we already know the answer. There should be a negative thing associated with it. You could right away mark the answer. And minus 1 by b, minus of minus 1 by a. So it's basically plus 1 by a minus 1 by b. Okay, there you go. Easy. Easy, 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 easy. Damn simple. That's it. Yeah, right away you saw 4 pi, you know that should have been the answer. Okay, now let's get into the next question then. I think this was a simple question. This could be solved in 2 minutes, even if you've done the integration. Even in this case, this could have been little more than 2 minutes. The first question could have been literally been less than a minute. If you apply the voltage ratio, voltage ratio logic behind your calculation. Sorry. Okay, so that could have been the easiest way of doing it. Okay, let's get into the next thing then. Next thing is going to be your problem around let's see what it is about. So to verify Ohm's law, a student connects very interesting. It's really an interesting question. The reason is it's actually interesting and definitely a new kind of model problems question that we haven't dealt up until now. So we have a voltmeter connected across a battery with internal resistance. What do you measure generally when you connect a voltmeter? Why do we not use a voltmeter to measure the EMF? Because a voltmeter, it can be even an ideal voltmeter, it will still measure something known as only terminal voltage. Okay, so a voltmeter is connected across a battery, and then you have an external resistance. Okay, so what is the thing that you are kind of changing in this thing? Student connects the voltmeter and the measure potential is plotted. Okay, so basically you are tuning the EMF of the battery to find out what okay, you're basically tuning the EMF of the battery to find out you'll be getting a current. Okay, you'll be getting a current and terminal voltage on the chart, using which you'll be getting a terminal voltage on the chart, okay, on this side, and you'll be getting a current on this side. Okay, so using which you have to identify okay, capital resistance or internal resistance, and then you also have something known as internal resistance and the value of R is also. Okay, and the potential difference across the battery when it sends 1000 milliampere current. With potential difference across the battery is not 1000 milliampere. It has already been told to us V naught is almost 0, so that is like 0. So potential, this fourth option is wrong. And if okay, let's solve this question. Let's solve this question. Okay, it's a simple question anyway, but first of all, let's do it from the graph and we will try to understand how to solve this question. Here we have terminal voltage, here we have current, and what are we measuring? You know that we are not measuring anything other than terminal voltage in this case. So what is terminal voltage? Terminal voltage, let's say this as an EMF R and internal resistance small r, then it's going to be EMF and the current I is flowing in the circuit. That means you are basically measuring that current I, you are going to measure E minus IR. Okay, that's what you are measuring in the potentiometer. That is what we have been doing throughout. Okay, now next thing, we know this thing. And what is that next thing that we need to know? We need to do it for 1.5 volts. We will start with 1.5 volts where current is 0. At this point, what is current? 0. We will find out R. First of all, let's see what do we get in this case. Okay, so we get current is 0 or I is 0. Basically, that capital I is 0. You can. So we know terminal voltage is how much? This is terminal voltage that we are measuring, right? 1.5 volts. 1.5 volts is going to be EMF minus current into internal resistance. But we know something, current is 0. Okay, current is 0 means this is 0. Internal resistance value is not what we are measuring. We are about measuring the potential of, EMF of the battery. The EMF of the battery is how much? 1.5 volts. But this does not tell us everything about the question. So we need to also calculate either small r or capital R. Okay, and okay, that is for 0 current. Okay, and given to us V0 is approximately equal to 0. We can keep this to be 0. Let's move on to the next page. I hope we got EMF. Okay, we got an amazing result. Next thing is just we need to find out either internal resistance or capital R. Okay, and then at this point we know it's 0. Okay, and how much is current? 1000 milliampere, which is how much? 1 ampere, students. Okay, so I in this position or in this place is going to be 1 ampere. Now what do we have? We are measuring terminal voltage, and the terminal voltage came out to be 0. So we know something like EMF minus I of small r is equal to 0, which is nothing but I into capital R. Okay, so probably external resistance is 0 according to this. So we know 1 is wrong. And then what do we have? EMF minus IR should be 0. We know EMF is 1.5. This thing, EMF is 0.5 volts, and then what do we have? I. Current also we know, right? We know 1 ampere. Very simple question. Okay. It's 1 ampere. Okay. I'm substituting that 1 ampere. I don't know. I, and then you have R is equal to 0 is equal to some 1 ampere into R external. You know R external is going to be 0. So this is 0. So we know option that 3 is also wrong. And then what we have? R is equal to 1.5. End of the story. Okay, we are making a mistake. It's not I into R external. That is where we are making a mistake. We're only measuring the current, and very big mistake. Okay, here lies the mistake, student. My mistake. Big mistake, my big mistake, my mistake. Let me correct this. Let me correct this. Okay, we write this down. Generally, this is the form we use. Okay, rest of the potential. Yeah, that's correct though. The leftover potential other than terminal voltage is consumed by. Terminal voltage is 0. That means all the potential has been consumed by this. So we cannot determine R external. Actually, it's not like R external is 0. That's my mistake. So we cannot determine R external. The reason is, this is fine because any potential is not left to drop across your R external. Okay. All the potential have been dropped just across the internal resistance. That would only be possible if external is very, very low, isn't it? Low is going to be near about 0. Okay, R external is going to be 0 then. R external is going to be near about 0. If it would have been given us like 0.0005 ohms, that might be true. Okay. So leftover potential is going to drop across. There is no leftover potential. All the potential has been dropped. Okay, so R external is going to be near about 0. Or should we say we cannot determine it? Just give me a second, let me think about this. That is correct. So current is 0. Oh no, current is not 0, potential is 0. Okay, my mistake again. Even though I'm doing it fine. So all the potential has been dropped across this. No potential is left to drop across R. That is only possible if R is less than that of internal resistance. R is near about 0. Very small value, that's it. Okay, let's move on to the next problem then. Answer should have been this the moment you found it right away. So this is not correct answer, we know that. Okay. Okay then, now we have an amazing question now of again your JEE Mains 2019. So we have a galvanometer and we have some arrangement of resistances, and what do we need to find out? Something like different voltmeters with different ranges are designed. Okay. Now in this case, we need to find out something known as R1, R2 and R3. Okay. So carefully, let me explain you this question. First of all, try to understand this thing very carefully. See, we have R1, we have R2 and we have R3. Okay. Now the thing is R1, R2, R3 are being measured. That means along with some resistance G, this is 0. Okay. Now in this case, what is happening? I'm just taking a random thing. This is not the answer, just taking a random thing. So up until here it's G plus of R. Over here this is G plus of R1. This is going to be G plus of R1 plus R2. And this is going to be G plus of R1 plus R2 plus R3. The moment you reach at this point. Okay, up until here this is G plus of R1. Okay, then it's going to be G plus of R1 plus R2. And then this is going to be G plus of R1 plus R2 plus R3. As you increase the resistances in series, what should be happening? The potential measuring capacity of your circuit should be increasing. So that means these are all fine except for option 4. Option 4 is given in the reverse way. As you're increasing resistances, you're not able to measure more potential. So that is wrong. And then students, what do we have? 2000 given to you. 2000 with 100 ohms can approximately measure anywhere between okay, sensitivity is given to you. Sensitivity 50 divisions, 15 to 20,000. So that's going to be like 1000 microampere, so 1 milliampere, 1 milliampere, and 1 milliampere multiplied with 2 kilo ohm resistance is going to measure you in around 0 to 2 volts. So among these given options, 1900 is the most accurate one. Probably we can keep this on hold. And then we have 1900 plus 8000. Okay, 1900 plus 8000 plus of 100 ohms. So that's going to be like 10 kilo ohms. 10 kilo ohms into 1 milliampere is going to measure 10 volts. Probably answer 3 is correct. And then we have plus of 10,000, another 10,000 ohms, so 20 volts. Yes, that's correct, doubled. Okay, so answer should have been 3. So let's get into detail solution. So what is being done? Let's observe this thing very carefully. So here it's 0. You understood that point. And this galvanometer as usual can only handle up until IG. How do you find out IG? Galvanometer full scale deflection current. You multiply, per division current with your, that is like your current sensitivity with number of divisions. Current sensitivity is how much? 20 microamperes. Okay. Into that of 50 divisions. So it can measure, it can handle up to 1000 microamperes, which is nothing but 1 milliampere. 1 milliampere is nothing but 10 to the power minus 3 ampere. Let's keep it as 1 milliampere. On to the next one. Don't forget this 10 to the power minus 3 conversion. That's what I would specifically emphasize on, because conversion is where if you make a mistake, but in this case you might not make a mistake because the values are given in such a way. And now what is happening then, it is being said at this first node you're able to measure 2 volts. So if you're looking at this first node, it's like G, some resistance should be associated with this, and there's going to be an R1. Okay, so between these you have to measure some 2 volts. This is clear. This is like a regular galvanometer questions that we deal with. Okay, galvanometer to like your potentiometer question that we deal with. Converted to voltmeter. Voltmeter, I'm really sorry, voltmeter question. That's not potentiometer. I'm really sorry. Okay, some 2 volts that you are going to measure. So what should be the V max in this case? V max should be something like Ig into that of G plus of R1. Be very careful about this. It's actually a very good question. 10 to the power minus 3 into that of, okay, we know V max is like 2 volts. We don't know the value of resistance. So V max is given to us as 2 volts, and we have G to be like 100 ohms, and we need to find out R1. Okay, so this is what we need to work around. What is that thing we need to work around? 2 volt, and brilliant question actually if you're noticing it carefully. So you're going to have something like 2 volt into 10 to the power minus 3. So it's going to be 2000 volts. Okay, 2000 ohms. 2000 ohms is equal to 100 plus R1, which is going to be like, R1 is going to come out as, from this thing is going to come out as how much? R1 should be 1900. R1. Very important to find out R2. You're noticing this. So, but one thing that we know, 100 plus R1 is how much? 2000 ohms. Just keep this in mind. You understood the second one. Third one is not at all a difficult. So now what is happening is, forget this. What do I mean by forget this is, what we are actually doing in this case is, we are measuring potential between these two. Basically these nodes. So this is going to look something like G R1. You added an additional resistance. Okay, you added an additional resistance. Definitely options are given to confuse you. So think very carefully. Very carefully means very carefully. Okay, now if I'm going to IG, etc. So it's very simple. IG is going to be like 10 to the power minus 3 milliampere. So this equation, right? G plus of R1 plus of R2 into that of IG should be how much? It should be 10 volts. Okay, should be how much? 10 volts. Now, of course, the next thing we want to do is substitute the value of G and R1, or rather I would like substitute the value of G plus of R1, just like 2000. Okay, so we have, and this is IG is 10 to the power minus 3. So 2000 ohms plus of R2 into 10 to the power minus 3 is equal to 10 volts. So this is going to be how much? 10,000 ohms, right? So R2 plus 2000 is going to be like 10,000 ohms, and you are going to have R2 as how much? 8,000 ohms. That's it, students. Very simple. 8 kilo ohms also is how your exam can be, like your paper can, your answer solutions options can be presented in. And then we have the last one, that's it, R3. If you understood this, R3 is not a big deal, but do keep in mind that the value of G plus of R1 plus of R2, from here you can say is like 10,000 ohms. Okay, this is what. Okay, this is something that you understood. Believe this is G plus of R1 plus of R2. If not, just to let me know. Okay, value of, again we need to do the same thing. That's why we are going to do this, right? So what are we going to do now is going to measure the potential between this point and this point. Right. You know the circuit? It's basically like an R3 you have, and we have something like G plus of R1 plus of R2, and this thing, how much potential needs to be measured between them, that's going to be like 20 volt. Okay, and other thing that we know is this guy is how much, 10 to the power minus 3 amperes, and this is how much equal potential has to drop. That is the easiest way to think about it. This is like 10,000 ohms, so 10 kilo ohms, what this should be. Okay, I don't think an explanation is required around this. G plus of R1 plus of R2 plus of R3 going to be how much? Into 10 to the power minus 3, that is Ig, is going to be 20 volts. So we know this value is how much, like 10 kilo ohms. Okay, plus of R3 is going to be like 10 to the power minus 3, 20. That means R3 plus 10 kilo ohms is going to be 20 kilo ohms. That means R3 should be 10 kilo ohms, which is going to be 10 to the power 4 or 10,000 ohms. Okay. Good question, actually. Definitely a good question. Okay, that's, you don't get confused. I think some options are given to confuse you, definitely. Which is that option? Let me just have a look at it. This is an option given to typically confuse you. Noticing the second one, this is just given to confuse you. So stay cautious of these kind of values. If you are looking at this video, you know the approach. Alright, let's get into the next question then. The resistive network shown below is connected to a DC voltage 16 watts. The power consumed by the network is 4 watts. The value of R is going to be out. One way is you substitute the value of R and get it, but that is going to be longer. Straight away solve it. That is going to be the easiest method. To simplify this network, what is the power consumed? EMF square by, or V square by R net in this case. That's it. Okay, first of all, let's simplify this network. That's all we need to do. Okay, so what is this? 4R and 4R in parallel, so it's going to be 2R. Okay, that is simple as it is. Okay, and then we have another R, and then we have 6R and 12R. How much is that going to give you? 4R, isn't it? But there is an R, so also use that R. Don't forget that R. That's going to be 4R, and then we have another R in C. So basically, it's like, whatever it is. So it's like 8R. This is how much? This is going to be like 16 volts. This is the equivalent circuit. First draw the equivalent circuit, and then the next thing is the watts, use EMF square by R. Okay, let's move on then. So this is going to be what this circuit is going to look something like this. It's going to be like 16R, sorry, 8R. 8R is what we have, is 8R. 8R is going to consume 4 volts, 4 volts, 4 volts, 4 volts. 16 volts, 4 volts, 4 volts is going to be, sorry, 16 volts, 4 watts, my mistake. If this resistor is giving out 4 watts. Okay, we know something known as power is equal to EMF square or V square, basically, by not even EMF square, terminal voltage square, right? That's the most appropriate thing, by R equivalent. That is going to be 4 watts. That implies 4 watts is equal to EMF, how much? 16 square divided by 8R. Okay, and what do we have? We have okay, that equation I'm carrying it again. Okay, you will have something like 32R is equal to 16 square. That's basically simplification now. 32R is equal to 16 square, so that should be like 8. End of the story. Let's move on to the next question then. I think this was a simple question. So cakewalks, many cakewalks in your current and electricity. Current and electricity is like a nice chapter where you can get many cakewalks. Okay, because one home cannot be the answer, right? Okay. Okay, students. Now I guess is this the last question of 2019? Probably this is no. We have one more question. That is that your 2019 paper is also discussed. Your 2020 paper is discussed. What is left over is just few questions rest of the years, which will be doing it selectively and finishing your PYQs. Okay, a moving coil galvanometer has a resistance of G and produces a full scale deflection when current Ig flows through it. The galvanometer can be converted into an ammeter of range 0 to I0 by connecting a shunt resistance Ra to it, and into a voltmeter of range 0 to V by connecting a series resistance Rv to it. Then what should be the answer? Ra into Rv should be G square. Ra by Rv should be like Ig by I0, and whether there should be like an Ra into Rv. So we need to do this question a little carefully, but so let's think about it this way. Ra by Rv. Ra is a very small resistance, Rv is a very large resistance, right? So in that case, let's think about this second term first. It's all Ra by Rv, Ra by Rv, Ra by Rv. So Ig by I0 minus Ig, this is applicable because Ig is the smaller value, I0 is the larger value. That means this is wrong. This might be applicable, and this might be same thing, isn't it? The difference between, probably this answer is wrong. Yeah, already got the answer. Oh no, there is a difference in. Okay, Ra by Ra into Rv should be how much? We can't determine that without calculation. Let's calculate it. Okay, can be any of these, but it's a very interesting question. So we have a galvanometer as usual, that is like G resistance, and then we have an Rv. Let's start with Rv. Rv is simple, and we'll move on to Ra. Ra is damn simple because Rv is simple, Ra is damn simple. Okay, Rv, and it can handle how much current? Ig current. Okay, and then what do we have? We know this is a galvanometer having a potential how much? like G I naught. Okay, this is a galvanometer having a, it's converted, sorry, this is a galvanometer with a potentiometer. Just let me just have a look at it quickly. A moving coil galvanometer produces a full scale deflection when IG current flows through it. The galvanometer can be converted into a nanometer of I to I naught by connecting a shunt resistance RA and into a voltmeter G into I naught. Okay, it's a very simple question then. So it can be converted into something like G into I naught voltmeter. Okay, so let's start calculating it. Now this is going to be like how much V is equal to IG into G plus of R of V. That means this is how much, this is like G into I naught given to you in the question. So let's just start solving this. And I naught is basically the IG. Right, that means if I'm going to simplify just the one on the left and the right hand, this and this would get cancelled out, and that is weird. I think that should have been V naught. Is this correct? Moment. I think this should have been V naught. The voltmeter, IG, G square, there's nothing in terms of V, right? That's really a different question, I guess. We're missing some point over here. It makes sense, yeah. This supposed to be 0. Yeah, right, that also makes sense. Oh my goodness me, my mistake, totally my mistake, student. We should have begun the calculation with I naught. Okay, my mistake. So the question says I naught is of the ammeter. It's not of the okay, I'll get to this thing. Okay, it's IG is basically current across your this thing. Current across your IG is the current across your galvanometer, whereas I naught is the current across your ammeter, total current that can be handled by the ammeter. Okay, that's where I made the mistake, I guess. So let's resolve that mistake and solve it quickly. There is a galvanometer G, and this galvanometer can be shunted with some resistance like RA, which is going to produce that ammeter. And this is little confusing question. Okay, anyway, it's a simple question. So here IG current can flow max to max, and the total current is how much? Total current can be I naught. That means how much current is going to flow through this? This thing, it's going to be I naught minus of IG. Is that what it is? Yes. So I naught minus IG will be flowing through this RA, and that's going to be like I naught minus of IG is going to flow through RA. And we very well know the potential is across this nodes, because they're in parallel, has to be same across G and RA. So it's going to be like G into IG is equal to I naught minus IG into RA. So how much is RA going to be? RA is going to be something like, okay, we'll get everything in terms of I naught. We shouldn't have cancelled out the I naught. That's the mistake that we did in that case. We could have started with RA. That could have been easier as well. Okay, RA is going to be how much? G into IG divided by I minus of I naught minus of IG. Okay, we have this, and then what do we have? That's it. We know this thing. And now the next thing that we need to do is calculate RV. Okay, calculate RV. Now let's calculate RV. RV, right? RV is how much? And we have something known as galvanometer, and how much it can handle IG. So we know RV, okay, this is G. RV plus G into IG is going to be how much in this case? the potential that this can handle. Okay, that's going to be 0 and some V that's given to us. V is G into I naught. Okay, G into I naught. So that's it. Okay, that's V. So let's just simplify this term. If we are going to simplify this term, it's basically IG into I divided by I naught. Sorry, I naught divided by IG. Okay, it's how much? RV plus G. That means RV is how much? RV is G. If I take out G as common in that case, it's basically I naught minus IG divided by IG. This is the value of RV that we have. Let's mark it as 2. Let's mark this one as 1. Okay, now the thing is, what do? We have to do two things if you notice the question. One is RA into RV we have to find out, other is RA by RV. RA into RV is going to be like G square. Okay, from 1 and 2. If you solve this, you will get an amazing result in this case. Okay, so RA into RV, we have the value of RA and we have the value of RV. RA was how much? G into G into like divided by G, isn't it? Or into okay, G into IG divided by I naught minus IG. G into IG, okay, no. This is where the mistake has happened. G into IG, that's correct, yeah. I don't know why this is going wrong. Let me quickly correct this. G into IG divided by I naught minus IG. Okay, we are talking about RA. Then we have RV. RV was how much? Something like G into I naught minus IG divided by IG. Okay, capital IG, small IG are the same. I just wrote it in 2 different ways because I wrote it one over here and then I had to like change it to the place. So we got RA into RV to be simply G square. Very simple, isn't it? And then we have the next thing that is going to be RA by RV or RV by RA. RA by RV. Okay, RA by RV should be a square. Okay, answer is going to be 4. Then right, answer is going to be 4. RA by RV is going to be G into IG divided by I naught minus IG and divided by G into I naught minus IG divided by IG. Very lengthy term, but actually it could have been a simple question. That's it. RA by RV is going to be how much? RA by RV is going to be IG by I naught minus IG whole square. That's it. We know the values. You can mark the correct option. That's the end of the story. The story is simple. Now we have the last thing of our 2019 JEE Mains question. We have discussed everything around your JEE Mains 1920. We have a few more problems left over. Post that we will be finishing current analytics. We'll be concluding current analytics probably next 2 sessions or 1 session. That's all we would be requiring. Current of 5 ampere passes through a copper conductor. So we have discussed JEE Mains almost every question here. 10 years past 10 years questions have been. Okay. Now this is the thing being asked. Okay, A current of 5 ampere passes through a copper conductor of radius of cross section 5 mm. Find the mobility of the charges if the drift velocity is 1.1 into 10 to the power minus 3 meter per second. Okay. Now, okay, drift velocity is given to you, and what do you have? You have to find out the mobility. It's a very simple question if you're looking at it. And what is also given to you? Resistivity is given to you. If you remember, what is conductivity? Conductivity is going to be N into mobility. Mobility is denoted by mu into that of E, right? And N into mobility, or N into mobility into E. Okay, that is it. Yeah, that is correct. And what do we have more? That means resistivity is how much? N into mobility into E. That's it, students. That's the end of the story then, because we know drift velocity relation, and we can say mobility should be like so should be like how much NEAVD. So this is like a very formula based question. Basic issue with this question, it's too much formula based. So NE into that of rho we have, and rho is how much? Rho is going to be like NE. Okay, we need to substitute a lot of values. Okay, then find out the mobility. Okay, that's it. That's what we have. So what is your rho going to be? Rho is going to be NE square by tau, and we can say just a moment. And yeah, here we have the solution. So okay, do we even need we don't have N actually. We don't have N. We are given drift velocity, current is given to us. Actually, we have to find out N. Okay, so current is how much? Okay, we know this equation. I is equal to NEAVD, J is equal to NEVD, and we can find out N from here. It's basically I divided by E by A into VD, and we know the value of N now. So substitute that, and you'll be getting some mobility is equal to something like mobility is equal to how much are you going to get this to be? 1 by N. N is going to be how much? Some current that has been given to you divided by EAVD. You can carry out EAVD to the top, and on the denominator you have something like rho into E. Substitute those values, you can simplify those, and when it comes to simplification, we need to definitely adapt a method that is going to be faster. And in this case, that is going to be like I will be cancelling out this and this, not worrying much, and then we'll be taking this as 5, and then this would be like 5 into pi, basically 3. It's like going to be 15, and we are going to have 10 to the power minus 2 on the denominator, 10 to the power minus 1. Then we have something like 15, 3.114, but anyway, this is not exactly going to be like 15, but it is going to be like less than 15 because we have 1.7 on the denominator and 1.1 by 1.7. So it's going to be something less than 15. 15 divided by 10, like 15 divided by 10, 1.5 should be the answer. 1.5 is not there. It's going to be 1 because it's going to be less than 1.5. Okay, 1.3 is also there. You need to accurately calculate this. Okay, this is a very calculation based question, so that's the reason I got the solution for you. There is no logic, nothing, no shortcuts, etc. This is the way to go about this question. That's the simple reason we have this solution. So simply use this formulas. Remember the formulas, 2 things that we have discussed. How do you find out conductivity? Conductivity is quite easy to remember. Mobility, very logical. So if you want to remember this thing, just a very logical way of remembering. Conductivity is nothing. Forget the resistivity part. You can later on do resistivity is equal to 1 by conductivity to get the same thing. But what is like your conductivity? Conductivity is going to be number of electrons per unit volume into mobility, which is directly proportional. Okay, conductivity is directly proportional to mobility, because more mobile, more conductive is that material, and similarly it's proportional to n, because more the number of electrons per unit volume, more conductive it is going to be, and of course it's going to be like multiplied with some E charge to find out the conductivity. So this is the easiest way to remember the conductivity formula, is what you want to go about. So n mu E, and then you want to think about mu. Okay, another thing that you may want to remember sometimes is, you must have seen like something like that is going to be like Ne tau by m is mobility. Mobility is equal to Ne tau by tau E by m, E tau by m. It's not Ne tau by m, tau E by m. Okay, you can check out yesterday's lecture for mobility's equation, and that's it. I is equal to NEAVD. That is pretty logical. So yes, students, this coming Monday from 10 a.m. to 1 p.m. we'll be having a PYQ session on your Unacademy learning app. 10 years PYQs of current electricity is what we are going to discuss. It's going to be a free of cost special class on your Unacademy learning app. So make sure you attend them, and you enjoy the sessions as well as learn from the session. It's not just going to be concept based session, but also tricks based session. Of course, last problem, just to try to memorize this equation, at least this equation, that should be fine, on the equation of mobility. And just a moment, guys. So mobility should be like E tau relaxation time by m. Okay, yeah, that's it. So this is the other thing that you need to remember. If you remember this thing, I is equal to NEAVD is a logical thing. You can check out my lectures and you'll understand how to remember those. And even mobility, we have a way of doing this. Okay, those are also discussed. Lesser the relaxation time, why more is the mobility, etc. We know that thing, etc. We know that, right? And yes, that's it. Do once check out this equation. I'm not very confident about it. I do not remember the formula, but anyway, this is fine. Okay, this is fine, and rest is fine. So anyway, we have discussed your 2019-2020 paper already on YouTube, but if you have missed it out, you can still start attending them on your Unacademy learning app with polls and leaderboards, and that way you will be able to get that 2 minutes. Within the 2 minutes, you will have to complete your your questions. Not only that, we'll also discuss shortcuts, tricks, etc. in this session. So do not miss it out. Also, concepts will be a revision for you. If you have attended it already, try and attend it within 2 minutes in the upcoming session. If not, do start attending it. We'll discuss other kind of shortcuts also possibly in the upcoming PYQ session. And that being said, students, one of the most important chapter, most important topic of your current electricity, that is subtopic of current electricity, is going to be electrical measuring instruments. Why? Because you can expect one question, a very simple question, just from electrical measuring instruments in your exam, in your JEE Mains exam. Typically, you can expect one question from electrical measuring instruments, a very practical topic. In fact, it can be a part of your laboratory topic. So don't miss it out. This is one lecture that you have to attend, worth just 4.5 hours, and having no price on it. So it's a free class, free special class available on your Unacademy learning app. So you can complete this lecture, complete lecture, everything around measuring instruments, electrical measuring instruments. It can be about your galvanometer, it can be about your voltmeter, it can be about your ammeter, it can be about your potentiometer, it can be about how to use that, it can be about your meter bridge, it can be about how to use that potentiometer to measure EMF, why potentiometer over voltmeter, and what is the application of potentiometer. You can use it, how do you use it to measure EMF, how do you use it to measure internal resistance, how do you use it to measure compare the EMFs. Everything can be done in this just one short lecture which is available for free of cost on your Unacademy learning app, which you can complete within 4 hours. And of course, students, you know what another amazing thing about this lecture is, this topic is you may definitely get a question in your current electricity from this topic. And given that you're going to face multiple papers, this is definitely one chapter that you have to remain strong for your JEE. Students, if you do not have Telegram app, download the Telegram app and click on this link. This link is available in the description box below, and then you know what, you will get updates, many updates, live before time updates on every class conducted by our JEE English team, be it on Unacademy learning app or JEE English YouTube channel, right? And you can get all of them on our JEE English channel, JEE English Telegram channel, basically JEE English YouTube channel. Just to click on that subscribe button and bell notification to get timely updates. And yes, if you get onto a Telegram channel, you will be getting live before time updates on every session conducted by our JEE English team, be it on Unacademy learning app or your Unacademy JEE English channel. You can also type in JEE_English to find us on Telegram. And students, yes, download Unacademy learning app. If you don't have an Unacademy learning app yet, just to type in Unacademy on your Google Play Store and App Store, and the first search result is going to be Unacademy learning app. Just click on this install button, because you want to have this app. I'll tell you why. I keep conducting A to Z sessions for your JEE one-shot lectures, and also we keep doing like PYQ sessions, trending sessions. Everything is available on Unacademy learning app. So these are all like fast-paced, full-length, high-quality lectures available for free of cost. If you want to attend them, just check out my profile and attend them. Other thing is, you can follow me to get the live updates. Just follow me and get live updates, live notifications, and you will be able to you will not even miss a single class. So you can follow your favorite educators, you will get live notifications, and moreover, we keep conducting free of cost national level quizzes, which also you can attend from your Unacademy learning app. So do download Unacademy learning app. And not only that, students, another important thing for you is we also keep conducting some national level test series where you can win prizes. If you have Unacademy learning app, you can do that as well. And students, that being said, yes, one such gamified IIT JEE battle, that is like one such event is going to happen on this coming Sunday. That is like in next few days, like in next 3 days it's going to happen. And this is not just for 11th class or 12th class students, but a segregated sessions will be conducted for 11th class, 12th class and droppers. So we will have batches for droppers, we will have batches for 11th class students, we will have batches for dedicated batches for 12th class students as well. So you will be competing with students of your same preparation level, and not only that, you will be competing with a national level crowd, with toppers, etc. And these papers or these gamified battles, this is basically going to be like a quiz. And these this gamified thing is going to be conducted by Unacademy, where the paper is going to be set by the best educators. And you will also get not only a very high quality paper, a very competitive and a good crowd, but also you will get access to dedicated solutions for each of the questions. And these are going to be like super detailed and solutions for these questions. So do attend it, compete live, and you can win. Also, it's also going to be a rewarding experience, and you can compete live and win Amazon vouchers, Apple iPad, MacBook Air, and Apple AirPods, etc. So enroll today, students, and make sure you apply Murli Live code, and apply Murli Live code whenever and wherever necessary. You can unlock many features, you can get many things for free of cost. You can avail the maximum benefit, you can get the best discount on your subscription purchases. So apply Murli Live code whenever and wherever necessary. And that being said, students, if you are looking for a complete package for your JEE Mains and JEE Advanced preparation, it's going to be an Unacademy subscription. Why do we say that? We have the best educators across the nation who are delivering, in fact, authors like DC Pandey and DC Gupta sir, who are delivering lectures regularly on your Unacademy subscription platform. In fact, you can attend daily live interactive lectures with these best educators on a very interactive platform with polls and leaderboards. and your learning would become super fun. Not only that, you will get access to national level test series set by the best educators, and you will be getting analysis post that, and using which you can improve upon your performance. Not only that, students, you will also get access to lots and lots of live doubt clearing session on Unacademy subscription programs. In fact, every single course, every single program is going to have live doubt clearing sessions. So you don't have to, in fact, worry about the planning. We take care of the planning on Unacademy subscription platform, and you will get access to not just one but lots and lots of live doubt clearing session. In fact, every fourth session is going to be a live doubt clearing session, and in fact, with every course you are going to get lots of quizzes and mega quizzes. Not only that, the other beauty of Unacademy subscription platform is that it's basically only one subscription and unlimited access throughout the period. Yes, it's like going to be like as many courses as you want to attend, no batch restrictions, etc. on Unacademy subscription platform. And students, how do you avail Unacademy subscription? First of all, download Unacademy learning app. It's going to be useful for your live notifications and to attend classes from anywhere. And students, not only that, do login, be it from a web-based version or app-based version, select plus, and then select IIT JEE as your goal, and then hit on this get subscription button. And now you will be redirected to a page where you will see multiple options, multiple programs, and which is the correct program for you. So let's say you are a 2021 aspirant with no plans for drop. We have dedicated programs using which you can complete, that is also going on right now, using which you can complete your with no plans for drop. Okay, you can complete all your preparation within 6 months. You can do that now on an Unacademy subscription platform. So if you have no plans for drop, if you are ready to prepare in 6 months, we have programs for you which can happen right now only at a price of 25,000. Here about 25,250. So let's say now you are a 2021 aspirant, but you have a plan for drop. You may want to go for 1 year subscription. And yes, you can be also 11th class student and you are well prepared, or you are a 12th class student and have a plan for drop. So you may want to go for a 12-month subscription, which is going to cost you near about less than 35,000, less than 2,900 per month, 2,888 per month. And students, let's say you are a 2023 aspirant. 2022 aspirant, we also have something amazing that is going to begin for you. So you can be a dropper in the 2020 aspirant. That is like we are starting classes by Bansal educators on Unacademy learning app. And let's say you are a 2023 aspirant and or a 2022 aspirant, or many more, maybe not a 2022 aspirant, you're not planning right now, you're a 2023 aspirant, and you may want to get started with an amazing program. That can happen right now because we have started a program by Vibrant Educators just recently, 2 days ago. You can start attending them, and even the program is going to be very reasonable. And if you have 2 years, it's going to be a 2-year long journey, but it's going to be an amazing journey on Unacademy, and all it is going to cost you is less than near about 25,200 per year. Less than 70 rupees a day is what you have to pay for a 2-year subscription. So this is about plus. We have something beyond plus known as Iconic subscription. On Iconic subscription, you not only get access to best educators across the nation, and not only just best educators, best program, best platform, etc., but moreover you will get access to one-on-one mentoring session, personal coaching from IITians and NITians who have previously gone through this journey. So think about it, IIT and NIT alumni who were able to successfully crack this exam will be guiding you with strategy sessions, and they have also gone through this journey. They know the ups and downs. They'll be giving motivational sessions, expert guidelines to take you through this journey, so you can get personal advisors based on your preparedness, etc. And this can happen now on an Unacademy subscription at a reasonable cost, and that is how much it is going to cost you, near about 34,200 for a 6-month subscription. For a year subscription is going to cost you 58,500. For 2 years subscription is going to cost you 90,000. That is going to be like 45,000 per year. Okay, that's going to be like 45,000 for 1 year. That is going to definitely be the most reasonable one, less than 50,000 a year. So you can get an Iconic subscription at less than 50,000 a year. But if you don't see this pricing, do apply Murli Live code so that you can get maximum discount on your subscription purchases. Right, that is something that you want to do. And students, definitely don't miss out any discounts when you are purchasing an Unacademy subscription. Make sure you apply Murli Live code and get maximum discount, be it 6 months, 12 months plus or Iconic subscription. Not only that, you can also apply it now on combo subscription. So what is this combo subscription? The combo subscription is a combination of your IIT JEE and board preparation from the best educators across the nation for your for at a very economical price, and this is going to be exclusively for you, where you want to prepare for both IIT JEE and plus at CBSE in one place. We have different varieties of this combo subscription. You can go for an iconic of IIT JEE and a plus of CBSE only at a price of 4,687, and you can go for a full iconic subscription only at a price of how much? 5,500. And students, you can go for a plus and plus, which is going to be the most economical one. And how much is that going to cost you? It's going to cost you 3,037 per month. And if you go for a plus of IIT JEE and iconic of CBSE, it's going to cost you like 3,900 per month. Make sure you apply Muralidharan code. Don't miss out Muralidharan code. That is going to get you a maximum discount on your subscription purchase. And we also have two convenient payment options for you, which I typically recommend to students. That is, one is pay in parts, where you can split your payments into multiple parts and you don't have to worry about paying it all at once. We also have something known as no cost EMI, where you have to pay any interest on your easy monthly installments. These are two typical options that I recommend to my students, but you can also check out other payment options like debit card, credit card, UPI net banking on Unacademy subscription. And students, we are right now an iconic subscription team. You can take your JEE preparation to next level with our personal coaching, with our personal guidance, etc. That can happen now with JEE English team. We have a team of IITians and IITians and head of coaching institutes. So make sure if you're availing iconic subscription, if you're looking for your iconic subscription in English, etc., you can do that now on with our team. And we have also, as I told you, started many batches for 2021 and 2022 aspirants. There's a few among them. So you have started a Super JEE batch 2.0 and a Striker batch 2.0 for JEE Mains 2021 aspirant, which has recently begun. That is before 5 days. And we also have something known as advanced micro batch that has been begun by vibrant educators for JEE Mains and Advanced 2023 aspirants. So this has begun on 13 Jan 2021, and we have something known as RM, which is for 2022 aspirants. And we have begun something known as Legend batch by Bansal class educators for 2022 aspirants. So these are some of the amazing batches that you have, and we have many more things actually going on. But not only that, recently these are some of the test series that are going to come up. So you can start attending them. One is Combat, as you know. Again, it is going to be conducted on 31st of January. And we have this race that is going to happen on 24th of January. We have a last mile target which is going to happen on 9th of January. We have this AIM paper that is going to happen every Saturday. So this is already completed, and unique DPPs every Monday and Thursday. And students, another thing is we have started a Manzilan Rank Booster 2.0 batch for 2022 aspirants and 2021 aspirants. Conducted by our best educator team. You can check them out as well. And students, do not forget to like and share this video, because we have completed 2019 PYQs, 2020 PYQs. Only few years PYQs are left. That is hardly going to take max to max few sessions, and that way you have complete revision, complete set of PYQs in one place on JEE English. These are all full length lectures, high quality lectures with all different kind of solutions, all different kind of shortcuts, concept based shortcuts that you can apply in your exam and quickly solve the problems. So do share it on your social media. It's a free of cost lecture, and click on that subscribe button and bell notification to get timely updates. And students, do not forget to smile, keep smiling, and work hard and smart to achieve your success, acquire knowledge, and keep sharing them. Work smart as well. Definitely do work smart. Avoid any gossips at this moment. And tomorrow at 6 p.m. we will be discussing your gravitation PYQs. Don't miss out gravitation PYQs because that's a very easy chapter, cakewalk chapter. So your PYQ discussion of gravitation will be completed very soon. So that is one of the things that you want to definitely attend. We will discuss all the PYQs. We are starting out with JEE Advanced PYQs. Okay, in fact, they are easy themselves. That way, think about JEE Mains, they are going to be easy as well. So this is what we are going to do tomorrow, and again at 7:30 we'll be having this current and electricity PYQ as we had today. And make sure you apply Muralidharan code to unlock new features on Unacademy Learning app to get the best discount on your iconic and plus and combo subscription. and anything else that you are trying to do, wherever code is required, do apply them.